Next example here is a little bit ugly to look at, right? I'd rather these were whole numbers or even decimals or something, but they're not. Same deal though, it doesn't matter what sort of numbers we're looking with. Same technique. Drop an altitude, make a little right triangle, and then we'll go over here and do some Pythagorean theorem. This 2 is not quite as bad as it would think. 2 root 2 squared, it really means 2 root 2 times 2 root 2. 2 times 2 is 4. Root 2 times root 2 is 2. So if I square 2 root 2, I get 8. Same idea, I get a 3 if I square root 3. And we've got our radius right there. We are now in business. We got a radius, we got a coordinates. It's just a matter of writing down the trig ratios, and there they are. So messy numbers don't necessarily make the problem harder. All right, last example, we're almost done. It says the cos ratio is 3/8. You might think that means x is 3 and y is 8. It doesn't. It's possible that x is 3 and y is 8, but there's many other possibilities too. It could be that x is 6 and r is 16. The ratio still is 3 to 8. I'm going to go ahead and think about it this way, though. Think about it with a radius of 8. That's probably the simplest thing to do. We're in quadrant 4 also. Radius is 8, so that means this is 8 units long here. Cos, that means the x-coordinate has got to be a little less than half. So I don't have to draw it perfectly to scale, but it would look roughly like this. Right? There we go. We've got a radius of 8 and an x-coordinate of 3. And we are asked to find the sine and tangent ratios and the angle. So now we're back to our usual thing. We've got a altitude here. We'll need to use a little bit of Pythagorean theorem, which I have cleverly worked out ahead of time. Oops, I got the wrong one, didn't I? So a little Pythagorean theorem, which is worked out there. So with a little bit of work, we get that missing side, and then we have the coordinates for the point, which are 3 and negative root 55, and then we can write it all down. As far as the angle goes, I'm going to try and find that little angle right there. I'll use a little SOHCAHTOA to get that job done. When I do, it turns out that little angle is 68 degrees. That's not really the one we're after, though, right? We're after the angle. At this point is in quadrant 4, so we're after this big angle here, which would be 360 minus this little part, minus 68, and that would give us 292 for theta. And that'll do it for today.